Okay, so we're talking about composite solids and working backwards. We're going to start with the composite solids. This first figure here, what are the two 3D solids that I'm dealing with here? A rectangular prism on the bottom. Now I want you to notice, whenever there is a multi-step type math problem, you really need to stay organized. You should label your work. Even if you're not turning it in, you should label it for yourself. Keep track of what you're doing. So I'm going to neatly keep two lists here. One for the rectangular prism and one for the triangular prism on top. For both lists, I need the area of the base, the perimeter of the base, and the height, which we defined as what? Distance between the two bases, right? It's on the board up there too, right? The height of a prism is the distance between the two bases. So you got to be careful of how you name your bases and find the distance between them. So I'm going to use this front as my base of the rectangular prism. What's the base of the triangular prism? It's the triangle. Okay, those are the bases. So I'm going to do the rectangular prism first. So if that yellow rectangle is the base that we've identified, and remember, you could have used a different face as the base of your rectangular prism. I would just suggest shading it in and making sure you keep track of, which one you use as the base. But we've shaded this one yellow, so we're going to use this. How would we find the area of that yellow rectangle? 6 times 3, which is 18. Perimeter of that same base, so it's 6 plus 3 plus 6 plus 3, again, is 18. Height of the prism, 10. Distance between the two bases, good. All right, on the triangular prism, the area of the base, what formula do we use for the area of the base? 1/2 BH, right, because it's a triangle. What is the base and height of this triangle? Good. 6 is the base, because it matches this one. And 4 is the height, because it comes down perpendicular to the base. So 1/2, 6 times 4 is 12. All right, perimeter. How do we find the perimeter? So we need the perimeter of this triangle. Do we know those two sides? Jack, how can we get it? Yep, we know that when the altitude drops down, it's 4, because they give that to us. That cuts the base in half. So this is a 3. Now we need Pythagorean theorem. 3 squared plus 4 squared equals x squared. You could do this out, or you could hopefully by now recognize, thank you, that this is a 3, 4, 5 triangle. Remember we talked about the most common Pythagorean triple that will occur is 3, 4, 5. If you have a leg that's 3 and a leg that's 4, the hypotenuse will be 5. That ratio works every time, and any multiples of that ratio, so 6, 8, 10. Okay, so 3, 4, 5 triangle, that makes this 5 and this 5. What's the perimeter? 16. 6 plus 5 plus 5. Height of that prism? Also 10. Okay, so we want the volume of the entire solid house-looking thing that's like stuck together. This is one big solid. We want the volume first. Because volume is more straightforward, I want to do it first. What is the volume formula for a prism? Area of the base times the height. So, very straightforward. We're going to do 18 times 10. We get 180. Volume of the triangular prism, again, still a prism, so BH. We've got 12 times 10, or 120. If I want the volume of the entire solid, what do I do with these two things? Add them together, and the total volume is 300. And since it's volume and it's meters, it's what kind of meters? Cubic meters. Okay, so let's talk about surface area. This one, remember, we said is a little bit more complex when we've got the solids stuck together, because where they're stuck together is not actually part of the surface, right? It's kind of stuck inside instead of on the surface. Yep. Do you have a question? Are you sure? So what is the shape of the part? It's a rectangle. The rectangle that's stuck inside does not get exposed to the surface. If we dipped this entire thing in paint, this piece on the inside, let me do highlighter. This piece on the inside, this rectangle right here, inside there, would not get exposed to the surface. It would not get painted. So we have to remember to not include that in our surface area. Okay, so I'm going to go with doing the full straight surface area formula, and then I'm going to want to subtract that out at the end. All right, so pH plus 2B is the surface area formula for a prism. I'm going to plug in what I know here. Perimeter is 18, height is 10, area of the base also 18, 180 plus 36 is 216. So that's the full and entire complete surface area of the rectangular prism on the bottom. So once we've done that, though, we have to subtract out the piece that's not actually on the surface. And we said that's a rectangle. What are the dimensions of that rectangle? Yep, so subtract out the 6 by 10 rectangle. So we're going to subtract out 60. So 216 minus 60 is 156. All right, so that's the rectangular prism. Let's deal with the triangular prism now. Surface area, again pH plus 2B. Perimeter is 16, height of the prism is 10, area of the base is 12. 160 plus 24 is 184. Is there any part of that triangular prism that we need to subtract out? Same rectangle, right. So we have to subtract out the 60 again, and we get 124. So now the total surface area, we just take these two things, 156 plus 124, and we get 280. Square meters for area, cubic meters for volume. Solve for one of the other pieces, right? So we've done these before, but we're gonna do them a little bit with volume and surface area now. Make sure you use the right formula, plug in what you know, solve for what you don't know. So in this first one, the volume of a regular pyramid is 96. Volume of a regular pyramid. What's the formula for volume of a regular pyramid? It's a pointy thing, so it's BH divided by 3, right? 1/3 BH. So that's the volume of a regular pyramid. So that's the formula that we want to start with. Now we're going to plug in what they tell us. They tell us the volume's 96, so I'm going to put that in for V. The next sentence says the area of the base of the pyramid is 36. What letter does that give us? Capital B, right? Area of the base is capital B, and they're saying B is 36. We're going to plug that in where the B goes, and now we can just solve for H. Very easy. What would you do next in this problem? Okay, so you could multiply both sides by 3, but sometimes it's good to check if you can simplify first, right? What's 36 over 3? So this really could be 96 equals 12H, right? 36 over 3 is 12. Divide by 12 on both sides, and H is 96 divided by 12 is 8. 8 what's? What kind of inches? Normal inches. This is just height. So it's not cubic, it's not square, it's just plain old inches. Okay. The surface area of a square pyramid is 473. The side of the square is 11. Okay, so surface area of a pyramid. What's the formula for that? 1/2 PL plus B. And they're telling us that the side of the square is 11. So the base is an 11 by 11 pyramid. So do we know the perimeter then? We can figure it out, right? Perimeter is 44, right? Because 11 plus 11 plus 11 plus 11. What's capital B? 121. Area of the base is 121. So surface area, they tell us, is 473 equals 1/2. Perimeter's 44. Slant height, we don't know. Area of the base, 121. So now L is the only variable left. We can just solve for L. What's L turn out to be? 16 feet. Plain old feet. Okay, this next one requires taking a cube root, which we didn't really get to practice the other day, so we're going to practice it now. The volume of a sphere is 288. Volume of a sphere. How do you find the volume of a sphere? Four pi r cubed over 3. Really? If they tell us that the volume is 288 pi, where does that go? In for the v, right? So 288 pi equals 4 pi r cubed over 3. What would you do next here? Multiply both sides by 3 first. You could multiply by 3/4 if you want to do it in one step. Multiply by 3, divide by 4 later. I'm going to do it in 2 steps, actually. Multiply by 3 on both sides. And this comes out to what? 8 something. 864 pi equals 4 pi r cubed. Now, we can divide both sides by pi, and the pi's cancel. And then divide both sides by 4. And what do you end up with? 864 divided by 4 is... Oops, not pi. We already got rid of the pi's. 216 equals r cubed. So if we want to know what the radius is, we have to do the cube root of 216. Right? Remember when things were squared and you wanted to undo them, you did the square root? Well, now it's the cube root. So I just want to show how to do that on the calculator. If you have a graphing calculator, oops, that looks like this. The math button, and then the fourth choice down is cube root. So math 4, if you remember, math 4 will get you cube root. Then you put in your number, and you get 6. Now, if you don't have a calculator that looks like that, look for a button that has an X root. Looks like that, an X root. On a calculator that has an X root, that's the button you use to find any root, like a 5th root, or a 7th root, or an 8th root, or a square root you could use, 3rd root, whatever. What they mean by the X is whatever root you're trying to find. So on those calculators, you want to put in the root that you want to find first. So for this one, we're doing the cube root. So you would push 3 first. You would push 3, and then this button, which on most calculators, it's a second function. So you would have to do the 3 first, and then second this button, and then put in 216, and then equals, and you should get 6. If somebody needs help with their calculator, just let me know. All right, this is also asking us for surface area. So surface area of a sphere is 4 pi r squared. So that's just 4 times pi times 6 squared. 4 pi times 36, which is 144 pi. Okay. And that's surface area, so it's square yards. Okay, number 4. Cylinder has a surface area of 144 pi, and the height is 21. Is this different than the one you have? That's good, because this is the one we did the other day. We don't want to do this one. I changed it on yours so that it was different than the one we did the other day. What numbers did I put there? 128 pi, and this is 12. All right, so that's what we're going to use, 128 pi and 12. Cylinder has a surface area. What's the surface area of a cylinder? CH plus 2b. Now, if we're going to solve for radius, though, what do we have to do to this formula? Yeah, we have to change the c to a 2 pi r and the b to a pi r squared. Everything else stays the same. So the h goes on there, and the 2 goes right there. Now, on your formula sheet, it actually looks like this anyway. So you could just pull it off your formula sheet, but if you think about it this way, you have to turn it into a version of that formula that has the r's in it. All right, now we're going to plug in what we know. Surface area is 128 pi equals 2 pi r, we don't know, h is 12, plus 2 pi r squared. If there's an r squared and an r in this problem, what are we going to end up having to do? Factor. To make our lives easier, what should we do first? What could we do to everything here? Divide by pi, and divide by what else? 2, right? So all the pi's are going to cancel. And then we're going to divide all of these things by 2. 128 divided by 2 is 64. This is basically 24r, right? Because it's 2 times 12, 24r. Divide that by 2, we just have the 12r left. Divide this by 2, and it's just left with r squared. So that's a lot simpler to factor, right? We got to get the 64 on one side and set it equal to 0. So r squared plus 12r minus 64 equals 0. What multiplies to be 64 and adds to be 12? 16 and 4. Positive 16 minus 4. So what's x? Actually, I don't know why I put x's. These are r's. R and R. So R is either 4 or, can a radius be negative 16? No. So radius is 4. So then it says find the volume. So you would just plug that 4 in and find the volume. Volume is 4 pi. Sorry, this is not a sphere. Volume is BH. Area of the base is pi r squared h. So this is pi times, we learned that the radius is 4, so 4 squared. Height, they told us before, is 12, so that's 12. So we got 16 times 12 times pi, which is, anybody have that for me? 192 pi. Good. And that is volume, so it's cubic inches. All right, I just want to point one more thing out before the bell rings. Let's look at the number 2 on the practice. So think of this as like a big pipe that you would put in the ground, like the water is going to flow through this big sewer pipe or whatever it is. Okay, it's a big concrete pipe. It goes, there's a hole through the middle. So let's think about surface area and volume. If I'm going to find the volume of just the pipe, we basically have 2 cylinders here. We've got the big cylinder, and then you've got the hole through the middle is like a smaller cylinder. What would we do with the volumes of those 2 cylinders to get the volume of the pipe? Subtract them. The big cylinder volume minus the cylinder in the middle volume, right? Okay, wait a minute. What about surface area? Okay, if I'm going to paint or dip this whole thing in paint, is that going to be more volume, more surface area, or less surface area than if there was no hole? More! There is more stuff to paint when there's a hole through the middle. So you actually have to do the surface area of the outer cylinder, add the surface area of the inner cylinder, and then add just the rings that are this is like shaded region area right here, right? So you add those 2 on, and you add the surface area of the 2. Yeah, fun.